Hello, statisticians. That's what Mr. Youngsaber says at the beginning of all his videos. Maybe I should steal his intro, because I need an intro for my channel. I wonder if he could sue me, though, if I stole his intro. We're going to have to look into that. This is Lesson 53, Part 2. Part 1 was long, 40 minutes. I know that that's way longer than you guys like. Hopefully, all the work that we put into Part 1 is really going to pay out in Part 2 and make this part of our lesson much shorter and much more manageable. We actually started on Example 2 in the lesson quiz for the first part. So as we go through this first problem, I'm hoping that a lot of the things that we write down are very familiar to you because the problem is almost exactly the same. So, just to briefly recap, I know sometimes my recaps are 10 years long, so I will try to briefly recap. What we talked about in the first part of the lesson is that if we meet three important conditions, our samples will come from a distribution or have a distribution that is normally distributed with a mean at the center and a standard deviation that can be calculated. That's the biggest takeaway. So if we meet three important conditions, our samples are part of a distribution that is normally distributed with a center at the true value of the population and a standard deviation that can be calculated. Why is that awesome? Why is that so cool? Because we can calculate some probabilities and we can investigate some claims by using that normal curve, using that normal distribution. Now, I filmed part 1 of the lesson twice. I felt like the first one was not quite everything that it needed to be. So in the second recording, I had you guys add a post-it note that gives you the formula for your Z. So if you want to add that in now because you didn't watch the newer version, please do. We're going to carry this over into our next two problems. So we learned this important thing. We meet three really important conditions. We can say this about our distribution. We checked those conditions for one problem. We did or found a probability in the last problem, and then we actually were able to evaluate a claim using the normal curve. So that leads us into Example 2. On these two examples, I'm going to do them exactly as you should do them in your Can You Do. So anything that I include here, you guys also should include, and anything that's not on here, you are not expected to put in your answers. If you like to organize this information in a different way, you are welcome to do that. Just make sure that everything that I have, you have. So it can look different, but everything needs to be there. Okay, so a sample survey interviews an SRS, so a simple random sample of 267 college women. Okay, I'm going to highlight that because I know that that is now my sample size. And that's what you should have put for N in your lesson quiz from Part 1. Suppose that 70% of women have been on a diet within the past 12 months. This is P. What is the probability that 75%, that is P hat, or more? I'm circling that because that's going to give us the direction of the inequality we need to write. What is the probability that 75% of the women in the sample have been on a diet? And that really should say in the past 12 months. I included that on the quiz because I realized here that it should have said in the past 12 months. Show your work. Okay, so First question is, well, how do I know that this one is P and this one is P hat? Well, first they tell me to suppose that 70% of college women, they mean all college women, have been on a diet. So they're referring to the entire population there. So here they're referring to a sample, but here they're saying 70% of college women. What they mean is 70% of all college women. And P hat, this is the sample they want you to investigate. They're saying what is. So whatever comes after the what is, that's going to be your P hat. N in this case, I'm just going to make a note up here, is all college women. So before we even get into this problem, let's think about our population size. All college women. So that's all of the college enrolled women in Utah and every other state in the United States. Maybe it even includes other countries, but I'm pretty sure it's just the United States. Is that going to be a lot of women? Yeah. That's going to be like 1 million plus, I would say. That's going to be 1 million plus. That's going to be a lot of women. Why am I having you guys think about this before we even do this problem? Well, because one of our conditions is going to require that we check that our sample size is not too big. And if I know going in the population that I'm pulling from, that's going to help me a lot when I decide if my sample size is too big. Okay, so what we need to acknowledge, first of all, is that we know the distribution from which our P hat comes from. So we're going to say P hat. And then we're going to do a little squiggly do, like you saw in your quiz. P hat is normally distributed with a center or a mean, mu sub P hat, that is equal to true P, which is 0.70. And a sigma sub P hat of P, 0.7, times 1 minus P. So instead of just writing it as 0.30 this time, I've actually written the 1 minus 0.70 because I was a little bit concerned that in the last note sheet that maybe I wasn't clear enough about where I got that 0.30. That 0.30 comes from doing 1 minus 0.70. So in this case, I've just written it out here for you just to be as clear as possible. All over our sample size of 267. Then I'm going to plug that into my calculator. So I'm going to hit blue button, root button, green button, y equals button. 0.7 times 0.3 divided by 267 is going to give me a sigma sub P hat of 0.028, and hopefully you already knew that because you had to calculate it in your quiz. Okay, so this is what enables us to calculate this percent. However, we need to check conditions now. And in the past, what I would do is list them out like bullet points. I would say, okay, the center's here, the standard deviation's here, then it's normally distributed, and that was very cumbersome. So I've decided the following is the easiest way for me to show I checked conditions, and I just go in order. So I just draw a little arrow, and I check my normal condition. So in order for this to be normally distributed, my large counts needs to be satisfied. So I'm going to do N times P, which is 0.7 times 267. That is equal to 1869, which is greater than or equal to 10. Now, you do not have to include that n times p. I'm putting it there so that you remember where I'm getting that, but you could have just written it like this. The next one we do is, sorry, I wrote that backward. I'm not sure why I did, because this should be, if we're doing n times p, it should be 267 times 0.7. Sorry about that. N times 1 minus p is 267 times 0.30. And that gives me, this is 186.9. I apologize, I didn't see my decimal. Which means that this one is 80.1, and that is greater than or equal to 10. So large counts is satisfied. The next thing I check is, how do I know that my distribution is centered on the true value? My sample has to be random. So did I take a random sample? Yes. So I'm going to say an SRS was taken. So under each characteristic, I'm briefly explaining how I know the condition is met. So large counts, random condition, and now our last one is the 10% condition, and that's where this guy comes in. So in order to calculate sigma sub p hat, it must be true that 267 is less than or equal to 1/10 of all college women. Do we think that that's true? Yes. Why? Because 2670, so that is our sample size times 10. 2,670 is less than or equal to all of the women in our population. Because remember up here, I said it was 1 million plus. So if I do 10 times my sample size, is that safe? Yes, 10 times my sample size is 2,670, which is definitely less than n, so I'm good on this one. This goes back to this idea. I can either look at it as 1/10 of n, which is what I have listed here, or I can verify that 10 times my sample size is less than the population. And essentially, I'm doing both. This is true. How do I know that? Because I did this in my mind. You decide what works best for you. You could do one or the other or both. If both of them, like if using both of them confuses you, I personally think this way is the better way to go. And I think writing the population shows that you understand better than just writing capital N. Okay, so that's how we check, that's how I check conditions. I write out the distribution, and then underneath I go through and specify how I know each characteristic is true. Now that we have that, I can just go in and calculate my percentage. What probability, or what is the probability of 75% or more? So they want us to calculate the probability, capital P, that we would get a sample, so P hat, greater than or equal to 0.75. Well, this is going to be equal to P, the probability of Z greater than or equal to some value. So let's find that value. I always write it underneath because I think it keeps my work a little bit cleaner. So we're going to do p hat 0.75 subtract p 0.70 divided by our standard deviation of 0.028. I plug that into my calculator. I'm just going to use my fraction button. So 0.75 minus 0.70 divided by 0.028 gives me a z value of 1.79. Because I have a 5 there, I'm going to round up to 9. So they're asking us to find the area to the right of the curve this time. But remember, on our z-table, they only give us areas to the left. So in order to find this area to the right, recall that we have to do 1 minus p of z less than 1.79. This is equal to 1 minus, we go to 1.79 in our z-table, and we get 9633. One minus 0.9633 is 0.0367. And now to finish up this problem, we are going to write our answer as a statement. So, the probability that 75% or more of the women in the sample have been on a diet in the past 12 months is 3.67%. When I write out my answer statement, I like to write my probability as a percent. It's okay to write it as a decimal. I just like it as a percent. How did I get this percent? I can times this by 100. So this times 100 would give me 3.67%. So you could either say in the past 12 months is 0.0367 or 6.37%. That's kind of good news. The probability that 75% or more is pretty small. The bad news is that means that 75% or less is a lot. Okay, one more problem, and essentially we do it exactly the same. A factory employs 3,000 unionized workers, of whom 30% are Hispanic. Okay, so this is giving us two very important pieces of information. 3,000 unionized workers, 30% of them are Hispanic. A 15-member union executive committee contains 3 Hispanics. What would be the probability of 3 or fewer Hispanics if the executive committee were chosen at random from all of the workers? Okay, so I know at this point that N is my 3,000 unionized faculty workers. And P is my 30% that are Hispanic. Now, before I go any further, I need to tell you guys to use pencil for this problem, and you'll find out soon. You got to use a pencil. Don't use a pen, or you're going to scribble some stuff out. Okay, well, what they're asking us to find is, what's the probability we would get a sample value of 15 executive committee members, of which 3 are Hispanic. So there, we actually have to calculate the proportion. Well, 3 divided by 15 is 0.20. And then this also helps me realize that my sample size is 15. So of 3,000 unionized workers, we are choosing 15 to be in the executive committee. What is the probability that 3 of those members will be Hispanic, or that 20% of the members are Hispanic? Okay, well, let's set up our distribution. So we know P hat comes from a normal distribution where mu sub P hat is equal to P is equal to 0.30. That's just saying I'm centered at the true value. Sigma sub P hat is the root of 0.30 times 0.70 over 15. I feel a little bummed that all these P's were 0.3 and 0.7. They won't always be 0.3, 0.7. So I plug this into my calculator. And I get a sigma of 0.1183. Okay, now we got to go through and check our conditions. So this is normally distributed if large counts are satisfied, which means n times p, or 15 times 0.3, is greater than or equal to 10. Well, 15 times 0.3 is 4.5. Is that greater than or equal to 10? No. 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 So what's happening here is I cannot calculate this for a committee of 15 people. I cannot do this calculation for a committee of 15 people. So I would have to stop. Even if this were a test question, I would stop there and say this probability cannot be calculated. The large counts condition is not met. However, we do need practice. We need one more practice problem where we can actually calculate the probability. So let's just make some adjustments. So instead of taking a sample of 15, let's make our executive committee 40 members. And I'm going to just cross that out and leave it, even though I can erase, because I want to jog my memory if I ever study these notes that there was an issue here, and I couldn't calculate it as it was. And instead of seeing if there are 3 Hispanic members of the committee, let's see if there are 8 Hispanic members. Oh, I was going to leave those numbers there. My bad. So I'm changing this to a larger sample size and more Hispanic members. Let's just verify that 8 divided by 40 is 20%, and it is. So I didn't change anything except for, or I guess I should say the only things I changed were my sample size and the amount of Hispanic committee members to account for the increase in my sample size. So now let's recheck this condition. And I'm going to leave the wrong answer there because I want to remember that there was an issue. N times P is 40 times 0.3, which this time gives me 12. So we barely passed the large counts on that one. N times 1 minus P is 40 times 0.70, which is 28. So large counts is now satisfied. Remember, you don't have to write this on your can you do. I'm just reminding us what I'm checking. Okay, center. The committee is chosen at random. So my random condition is satisfied. And now my 10% condition. This is the first problem where we can actually check the 10% condition using real values. So we're checking that our sample is less than or equal to 1/10 of our population. Our sample is 40. This is the first time we know our population size. So is 40 less than or equal to 1/10 of 3,000, which is 300? And the answer is yes. So all of our conditions are met. Okay, well now we are calculating the probability, capital P, that we would get an executive committee, so that's my P hat, where 20% or fewer are Hispanic. This is the probability of some z-value. What z-value? Well, 0.20 subtract 0.30 divided by, I forgot to recalculate this guy. So this I have to change to 40, which means this, I'll calculate it for us, is now 0.0723. So I'm going to go with 0.072. Just as a reminder, where am I getting the calculation for my z-value? That post-it note on our notes for, sorry family, this post-it note. Okay, this gives us a z-value of negative 1.38. Okay, I had to pause, sorry, I had a teacher come in. So with my adjusted standard deviation, I plug that into the formula for my z, and I watched it back and realized that I showed you my post-it note for like a half a second. So this is the post-it note where I have the formula for z. When I plug that in, I get a z-value of negative 138. This is to the left, so when I pull my z-table this time, I don't have to do any 1 minus, anything like that. I go to the negative side, I find negative 1.3, go all the way over to 8, and I'm getting 0.0838. I'm just double checking. If I want the percentage for that, I can times by 100, and that would give me 8.38%. So now I just finished this problem by formalizing my answer or writing my answer out. And I typically just take it straight from the question. So the probability and I think I might change it just a little bit. The probability that 20% of the executive committee I don't think I can do that. I'm so sorry. Don't stray, teacher. Do not stray from the prompt. The probability that, here it says 3 or fewer, but we changed it to 8. 8 or fewer Hispanics being randomly chosen for the executive committee is 8.38%. So that's not unreasonable. It's not unreasonable that even though the population is 30%, that if you randomly chose the committee, you might get a proportion as low as 20%. I mean, it's not very likely, but it's not impossible. So the probability that 8 or few Hispanics being randomly chosen, so that shouldn't say that, the probability of. Okay, so that is it for this part. Try your questions below. They're just the calculate the probability part. So you don't have to check all these conditions. You're just finding this very last number. And then your can you do actually isn't very long for this lesson. It's a few of these practice problems. And remember, the amount of work you're expected to show is about the same as here. And you can show that you're checking these conditions any way you'd like. Just make sure you have included everything I have included. Okay, that's it. Love you guys. Email me with any questions you have.